Now we have to plan ahead now. What are we going to do for our subnet masks? The recommendation is start with your smallest subnets first and then enlarge them, because as you do small subnets, you don't want to overlap them with the larger subnets. So even though the specs are given us in random order, let's do the tiny subnets for those serial ports. There's 2 hosts on either side of the serial port. So what number should I use for the first tiny subnet? You can decide. Usually you start either at the top end or the bottom end. Let's just start at the counting from 0. Who can tell me what my first subnet would be for the serial lines between the routers with only 2 devices on them? How large would the subnet be? How many bits in the subnet mask? So we'll do the first one, or number 2. 2 hosts. How many bits in the subnet mask? Lloyd is suggesting /3. What do you think, Jonah?
Sorry, /30.
Oh, /30. Oh, you want even more. You need 2 hosts, and you're going to give me 30 subnet bits.
Oh.
What do you think, Jonah?
Oh no, 2 subnet bits. Sorry.
Oh, yeah.
2 subnet bits.
Yeah.
/30 network.
Right. I see what you're saying. Yeah, /30 network, 2 bits. 2 bits needed. You are correct. He did do the correct /30. That is the correct number. That's right. So 2 bits needed in the host side. So it'd be /30. Okay, what would the number be /30? What would the network number be? Or we'll call it net 1, net number 1. That would be the correct subnet mask. What would the network number be?
Oh, network number. Oh. 172.21.0.1.
You don't have to go .1.
Oh no, that's 0 for the network.
.0. Yeah, 0.1 actually wouldn't. I don't think it would give you an error if you specified that. It would just throw away, if you did a /30, it would throw away those bottom 2 bits of 0.1 and say, oh, I know what network you're talking about.
You don't have 1 host.
Yeah. Well, actually, it would throw away the 1 because, say, I'm ignoring that 1 bit you gave me, and it would apply the network 172.21.0.0. And how I like to write it is this. I would like to write 172.21.0. And then that last octet, I like to write it this way as 0.0.0.0.0 and then little O's to remind me that those last 2 bits are my host bits. All right? Mr. Stephen, what would the next subnet be for my routers? The next 2 hosts on the network. What would the next network number be?
172.21.
What?
0.1.
0.1? Got a problem with that. If you put a 1 there, that would be a 1 in this bit. He is on that network. You're naming the host of Lloyd's network, and you're tromping on Lloyd's network. He's not going to be happy.
Steve, get off my network.
And the actual router would say, sorry, that's overlapping with an existing interface.
0.6.
Think about what this means. So I write it this way. The large numbers are my network numbers. You cannot have the same network number on 2 interfaces. I need a different network different subnet. So these numbers can't be the same. These numbers here can be the same as long as something's different, not exactly the same as Lloyd's network. So what I need to do here, what number do I get if I change this to be the next network, the next subnet up? What if I put a 1 here? What do I get? What? I think I heard it. A 4, you're correct. So 4 slash, how many subnet bits? Yeah, it's still 30. If I tried a bigger number, that would would turn that 1 that I just set, it would be a different subnet. So 172.21.0.4, and I'll write it as 4. I'll write out the bits in this last one. Put a 1 there, and then my 2 host bits. See how the slash 30, and I think this is a good way to visualize it in your mind. Think of the byte that's being subnetted or broken apart. Think of the bits in that one as you deal with your subnets. All right, Jonathan, what's the next network? We only need 1 more because we don't have those 3 routers. What would its network subnet mask be for the third tiny subnet between 2 routers? I only need 2 devices. 0.8. Let's see here. That last octet, that sure looks like the right number. Yeah, 0.8/30. And once you do a couple, you realize, oh yeah, they just go up by 4 each time. All right. Now, the next larger subnet, question 1 here, to our Cisco expert, soon to be Cisco manager, head network guy, Mr. Jonah, working at is it RSM?
Yeah.
RSM Cisco guru. What is the network? We need 4 subnets. Actually, 6 subnets. Oh no. Which one is the next larger one? Oh, 3. 3 subnets with 10 hosts with the smallest possible subnet. What is the next possible network? We want to go up in numbers. Since we started the scheme, we're going up. What is the first available subnet that'll allow me up to 10 hosts?
Up to 10 hosts?
I need 10 hosts. Give me the smallest subnet that will hold 10 hosts.
But we actually need 12 spots though, because we need to account for the broadcasting and actual networking.
Yeah, you're right. You have to allow for 10 hosts, but the network number and the broadcast address
It'd be a /28, right?
I would select 20.
/28 because, or 4 network bits, because if you do 3 network bits, you'll only have 7, and if you do 4 network bits, then you have 16.
Right. So I'm going to jump right ahead, and then I'll come back and fill in my network. So I'm going to do 172.21.0. Now, you haven't told me yet what goes in the bits, but I know I'm going to need 4 host bits, right? Because 4 host bits lets me count up to 16, and I'm only going to use, I only have available 14, so I'm going to have actually 4 spares, but you have to go up. You can't say, okay, this is only going to give me 10. So what goes here in the bits for that network, and then we'll come put it in decimal form.
Would it just be, you mean escalating, like, going through the different numbers?
I need the next possible network.
Wouldn't it be just .0?
Like that?
Yes, that's right.
Yes.
Look, you're overlapping with this guy.
Okay, so we can't. Oh, we're not trying to overlap.
Yeah.
Oh.
So I would. This is my first /28 network,
So
but
out of one.
yes, because the /28 network, he's been subnetted already. I can't use anything that would overlap with this guy. So I have to use not the first /28. I have to use the second possible 28-bit. And since I specified, let's go up to the very next one. You could have said, well, let's just be safe and make that be all ones. No, the very next one has to be different, even though I'm using 6 bits here. If I try to overlap, I say, wait a minute, I can't have those bits ever be the same as any other network if I'm a /28. Okay. This is a great practice for you to, and this is, you do this once, you realize, oh, variable length subnet mask isn't that bad. All right, so we've got that network. So what does that look like in our actual network number and subnet mask? 172.21.0. What'd you say, John? What's 0.
So that would be 0.32.
32?
Or no, 16.
16, right.
I was off one.
/20.
It says 28.
28. Very good.
So then the next one would probably be .32.
Well, let's find out. Network number 5. This is Elisha's turn. Oh, have we made it? Yeah, Lloyd did one. Elisha's turn. Then we'll go back around. What's the next network? I need 3 of these.
32. 172.21.
Yep.
0.32.
And once you do a couple of them, you realize, oh yeah, it just goes up to the next one. And to help make it clear, 172.21.0. And write it out the bits here, 0010. And then my host bits. I have 4 host bits left. All right. I'll do. Let's see. Back to Lloyd. What's the number 6?
That would be 36.
Yeah, very good. Getting easy, isn't it?
Yep.
Once you do a couple, it's like, oh yeah, same number of subnet bits. The next one. What did you say it was?
It's not doubling. You're just adding 4, so it'd be.
Well, it's by powers of 2, so this one.
Oh, by power of 2, so 64, yeah. Wait.
Let's look at the bits over here.
Oh, yeah, no.
172.21.0.
48.
Yes. So 001011 is the next one in line.
Let's see. It's right, binary.
That's why writing out those bits is super helpful.
100.
Yeah. And the clue here too is, hey, we went up by 16. So once you see the sequence, oh yeah, it's going to go up by another 16. So that's another way to look at it is, oh yeah, if they're the same size as the previous one, once I get the first 2, then it's just the same number between. Just like we did 04, oh yeah, it's just going up by 4 each time for the next subnet. So those are my 3 subnets with up to 10 hosts. Let's just do the first couple of the subnets with at most 40 PCs. And what was it? I jumped to Stephen on this one last time. So Stephen, what's the first sub? This is the hardest one. I'm giving you the hardest one. Network. This is network number 7. I need 40 PCs. What is my network for my 40 PCs? We're subnetting a class B. What would be a network? Think of this, how many bits do I need to include at least 40 PCs? How many bits do I need to have at least 40 PCs in the host section of the subnet? So you think to yourself, how many bits do I need to make that the host part? Let's see. That gives me 2 hosts. That gives me 6 hosts. That gives me 14 hosts. 5 bits gives me 30 hosts. Do I need 6 bits in my host portion in order to get 40 hosts? 5 bits, I can only get 30 squeezed in there. So I need 6 bits in my host portion. And now I need 8 bits total. So how many, or what are the bits going to be in my first subnet? And those top 2 bits, can they be 00, 0? Well, that'll overlap with that network. So what do I put here?
0, 1.
Yeah, 0, 1. And that gives, and let's make sure, does it overlap? None of these have a 0, 1 in them, so I'm okay. Notice if ever I went to another 10-bit subnet, or 10-host subnet, I would be pushing a 1 there, and I could no longer use a 0, 1 in my 6 host bits. I would have to make this a 1, 0. I'd have to jump up to the next subnet. So remember, I could never overlap with the previous network's bits that represent that subnet. So I guess I kind of gave it. I should have given you 4 in this one. Then you would see, wait a minute, I have to make sure it's not overlapping with a smaller subnet's network bits. So the number then would be? You are correct. Slash, what would the number be of subnet bits?
32. 42, right?
Not 32. That would be one host. That would be a specific host. How many bits in the subnet mask? It's going to be less. I'll give you a clue. It's less than these because I have more host bits.
26.
Yes, 26. And then to display that in bit octet and then the very last one in bits, I would do that. This is my technique I invented. I think this is a cool way because it's easy to do in text files, and it makes it clear to you. And whenever I'm looking at bits in my that are network bits, just make them larger. And if I ever designate hosts numbers, I'll put little letter I's in there so I can see that. Sometimes you'll see it bolded if you have a fancier editor. So last one. Who did that? Delaney. What's the next network? This is our last network. We'll forget about all the others. 128 slash 26. Let's see. We come over here. 172.172.21.0. Let's see. That would mean that's a 1, 0, and then the rest of host bits. Yep. Doesn't overlap. Counts up to the next one. And the next one in line, just another 64. We'll just add 64 to that, and I'll do that one since I haven't done one. I'll do the easy one. Once you see 2, same number of hosts, 172.21.0.128 plus 64 makes 192, right? 26. And as I go up, I would actually start getting into these bits, and then I'd be breaking up these and knowing, hey, those are all host bits, so I know that number is going to be a 0. I'll start breaking into these as I go higher. I'm not going to make you do that. Let me do one. Let's see, that would be the last one. Let's see, 172. 21.0. Now be 11.0.0.0. Oops, host bits. So that's easy. Now let's do the next one. Just to make sure, I'm going to do this one for you. And you tell me whether I get this right. 172.21.1.0.0. 0/26. Is that right? Let's see. 172.21. I'm going to put all these now in bits. 4, 5, 6, 7 bits. There's another host bit, and then all of these are host bits. See how? Oh, messed up. There's a 1. Oh, I messed up. You didn't catch me. It should be 2.0 because I need to use this top bit. See how I'm using up that bit? I need to use this bit. Wait a minute. Did I get that right? No, sorry. I did have it right. What am I doing? 0, 1, 0, 0. There we go. I can do that. So 1. So it's still the same subnet bits. I suddenly, for some reason, my brain got me going into, because I'm switching over here. Suddenly I had this became a host bit. So there would be the next one. See how then these, I start worrying about what those bits are, and I can just say, well, I know this is all 0 because we're counting here now, but then that one would become a 1. So because I'm subnetting across 2 octets, I start breaking both of them into bits, just so I can see how I'm counting up on the network portion. So I'm not going to make you do all of them, but remember, when you can't just keep going up by 64. Once you go past this boundary, well, now you start having this guy start counting up, and this will become then a 64, 128, 192. This will become a 2, 0, 64, 198, 22. Okay, enough of that. Time for a little hands-on with Wireshark. Go to Schoology and download a Wireshark capture. You're going to be a forensic investigator and just have to answer a few questions in the activity. Let me bring up the activity. It's in the quiz portion on Schoology. Make sure my attendance is saved. Horrible user interface. You save changes. The save button remains highlighted, making me think, did I push it? Or is it not really saved? So in the quiz section, down here, I decided to put it in the quizzes because I want to treat this as kind of not a module 1 through 8 exam. Where did it go? Oh, sorry. Did it go at the bottom? Where did it go? Assignments? I put it in the wrong course. I just did it this morning. Where did it go? Is it at the bottom of the assignments? There it is. Sorry, it's the bottom of the assignments. I thought I had put it in the quiz section. Bottom of the assignments. All I need you to do, download this capture file that I created for you, and all you got to do is some forensics. Someone has captured this file and has provided this to you. Say, tell me what happened on my network. And I have a few questions asking you, okay, when exactly was this capture done? So I'll go ahead and download that, save it in any special place where you want to save it. Wireshark Student LAN. This network here is a little more boring to watch traffic on than the student LAN. This is 1 minute of traffic on the student LAN. And because I have Wireshark installed, I can simply click on that file. Wireshark knows to open it, and I have it over here in Wireshark. First question is, when was this capture taken? Assuming the clock on the PC during the capture was correctly set. That is one big assumption that sometimes people that want to mess with the network will change the clock and do things, and then change the clock back, and it messes up the forensic people. When was this captured? Can you tell exactly? Take a look at any packets and click down below here in the details, expand the frame, and look at that. You see arrival time 7:28 Central Daylight Time. It gives you an epoch time, which I'm assuming is the fine exact number in your system clock. I haven't done research of where it gets epoch time from, but I have it written in nice human readable format. Now, can you figure out, is there a way to copy that line? Hey, Jared's here. How you doing, Jared? Let's present this screen to you. We're doing a Wireshark capture here. It's in the assignments on Schoology. We're going through this little assignment here. Go down into assignments, go down to Wireshark capture analysis. This is like just a class time activity. We're going to answer all these questions right now. So,
We need to submit this.
Okay.
and so all you're doing is creating a Word document, and you're just going to submit it to this as once you have the activity completed. So just upload it right here.
How
Once
did
we're
you
done.
pull up the time again on that?
Oh, let me show that. To get the time, just click on any packet, and down here in the details, expand the frame,
Oh, there it is.
and then you see arrival time.
Look, I just took it down.
And that's packet number 1 in my capture, and so that's when my capture started. So anytime you're giving up Wireshark capture from the forensic people who say, hey, something went down on the network, you could actually have a system out there continually capturing packets or trigger to start capturing packets based on a signal from something else. It'd be a really cool intrusion detection appliance. You might actually invent them, and you could, with just a little programming skill and Wireshark knowledge. Wireshark does provide an API interface. You could have a program that somehow sees or gets signals some oddity, maybe by watching traffic. And when you see some oddity happen, you start a capture. Okay, so now you're an expert at finding the time that capture was started. What is the IP of the machine that is capturing the packets? I give you a little hint. Or I don't give you a little hint, do I? I can give you a little hint if you can't figure it out. Can you figure out what is the likely address of this machine that is capturing the packets? Because we're going to need that number for some of the filtering we want to do. Can you kind of guess what machine is doing the capture? Think about when you're watching the network, and you're not on a switch that has a port that's mirroring all the traffic to you, which would be a horribly slow connection for you, because you're processing all the mirror traffic to everything on the network. Can you guess what is the IP address of the machine doing the capture?
Oh yeah, it's 10.130.1.44.
Nope.
Oh, I guess it's only the first packet.
It's 10.30.2.246.
Nope.
Yeah, so we're watching the whole network, so we gotta.
One clue is what traffic is not broadcast? ARP is a broadcast. UDP, that's, I'm not actually, some of these I'm not sure why I saw the traffic, knowing what my IP address is.
IGMPV3.
I'll give you a clue. TCP protocol is not broadcast. So I will only see TCP that's either coming from or coming to me. So you can click the protocol header and you can actually sort by protocol. Can you see which number is common to all the TCP protocol? Yeah.
So
Okay.
in those instances, what's a good way to tell the difference between like you being the .98 and then you communicating with the .221 or
Right.
243 or anything like that?
Yep. I'm going to show you that in the next filter. wonderful question. It's like I cued you to ask that question. Okay, so you've got the capture. You know what your IP address is, and I put a little explanation in because TCP traffic, TCP protocol, is either from or to that IP address. That is going to be my address. So the question is, I want to display everything else. I want to display not the things that are being sent or to or from me. So I needed to know my IP address. And let's just let me show you this thing I can do with display filters.
Wait, so why are we assuming it's 10.28.7.98?
Because TCP protocol traffic, which is what I'm either going to be sending or receiving, that is the number common to all the TCP protocol traffic. That's how I deduce that that's my address.
That's all the address coming to the
Yeah,
device.
TCP is either coming to me or from me. So my address is either going to be on the source or destination side, and that's 10.128.7.98 is the only one that's common to source and destination of my entire list. So here's what I do to filter out everything that is not to me. First of all, I'm going to start with a filter, and I'm sorry I can't make that text larger. IP, up there in the display filter, type IP.addr. It gives you a little bit of autocomplete help. And I can do double equal, addr, double equal, and then I put the address of the machine that's doing the capturing 10.128.7.98. That's one filter I can do. And what that does, it's the traffic that's either to or from me. In that, there's an IP address to or from me, and I get how many packets? I get 1,100 packets displayed. Down there in the lower right, I can see how many packets there are to or from me. So to see what's not to or from me, I thought, well, maybe I turn that into a not equal. No, it doesn't like that. That was my first attempt. Think, okay, I can't do that. I have to do this. In front of everything, do a not, exclamation point, and then parentheses around the address is mine. Now apply that filter, and now you will see all the traffic that is being broadcast. And it's not just ARP. And there's the number, 3,026 broadcast packets being seen by this PC in 1 minute on the student LAN before classes started. If I ran that in the afternoon where there's a lot of activity, I'm just wondering how much more I would see in a minute at that time. I'd say the network's probably pretty quiet around, what was it? It was about 7 o'clock. No, actually, it was around 7:30. I finally got this working. So here is your filter. Your filter would be, let me put that in large text so you can read that, because that's kind of small. This is a Notepad++. The filter for all traffic not to me, and I have to know my IP address. Maybe there's a way to do like IP.mine or something. I do not, parenthesis, IP.addr, double equal, and then the address of the one doing the capture. In this case, 10.128.7.98. That is the filter. That's the capture filter. No, not the capture filter. It's the display filter. And crazy thing is, capture filters aren't the same syntax as display filters. But we won't worry about that. If I only want to capture broadcast address, I'll just tell you, if I wanted it on the capture filter, just for fun, you don't have to put this, but it's good to know, capture filter would be not host 10.128.7.98. Completely different syntax on a capture filter. Kind of irritating. The reason I would do it on a capture filter is because I'm capturing a ton of things. If I want to save my disk space and I know exactly what I'm looking for in the network, I go to a capture filter. So I'm not capturing everything and then doing a display filter. Okay, so that's just extra for you. Question?
So what's broadcast traffic?
That's what this is doing. Display anything that's not to or from me. Well, I'm pretty sure that's all broadcast traffic. Even though destination doesn't say broadcast, you see destination to these other things. So I can go sort them by number and sort them by protocol now, and I see that ARP is a big part of that, but if I go further down, I see there's other types. So the next question I think was, list for me all the types, was it? Let's see, check that.
What was the command again? So it's an exclamation mark.
Yeah, exclamation mark, parenthesis,
IP address of the machine.
ip.addr equals. Let me show you that in the notepad file. There's the filter right there. Not ip.addr double equal my address of the guy doing the capture, 10.128.7.98.
What's that capture filter below it?
This is if you actually turn on a capture filter. There's in Wireshark there's display filters and there's capture filters. You can before you start a capture, you can say only capture this activity that's not going to or from me. Like if you're running a server and you want to see what else is happening on the network, this is a very useful capture filter. And I'll just show you that. If I want to start a new capture, I can go capture options and I can tell it what capture filter to use right down there. I'm not asking you to do that. But
I don't know why mine isn't wanting to show just the broadcast stuff. It has other stuff in there too.
Let's take a look. How many do you have? How many packets are showing displayed down in the lower right? What does your display number look like? Way down the bottom bar.
Displayed 2026.
Yeah. I'm just clicking on protocol. I'm sorting it by protocol by clicking here. If you click on sort by number, you'll see this. So you click on the header here, it'll sort by that thing. So if you actually want to look for, hey, what particular devices are being involved here, I can click on source, and I see this particular guy is doing the ARP broadcasts it's not a particular sequence. So this is very helpful. If I want to do the next thing, like what are the protocols that are being essentially broadcast that I'm seeing, they're not to or from me, I can click on protocol, and I see that ARP is a major part of the broadcast address. And how many ARPs are there? That's the next question. Here's how to do a filter to count how many ARP packets there are.
So the one question, it says apply display filters only do broadcast traffic. You get a screenshot.
Yeah, so do a screenshot of this. Once you apply the display filter, just do a screen capture.
That shows that we have a filter in place then, right?
Yeah.
Okay.
Yep. So now I know that ARP is one of the filter things, or one of the broadcasts, or the major broadcasts. So how many are there? I could count through here, copy it to a text file and count the number of lines, or I could come up to my display filter and simply put ARP in my display filter. Just the word ARP, hit enter, and it only shows me the ARP packets, and it tells me that down here in the display there are 945 of them. In 1 minute of capture on the student land, 900, almost 1,000 ARP packets being sent. So ARP is keeping my network. You think, well, that's super busy. Well, remember, we got a pretty fast network. Let's maybe watch it for a minute when it's super busy and see what kind of traffic we get then.
That's 15 ARP requests a second.
And I can always go back. It remembers, I think it remembers the filters I've done, so I can go back and then right click, the little pull down, and go back to my display and sort by protocol. And the next protocol, after I go down 975, I see I think it's alphabetized. I grab the slider. The next protocol, there's just a few of these other odd protocols. There's one browser host announcement in the classroom 26. And that, I think, was John Marchant. I don't remember if he came and I don't think he was there. Something happened on classroom machine number 26. There was suddenly a host announcement that got broadcast. I don't know what those are, but I might do a little investigation. You don't have to do any investigation. Just say there's one browser, there's one CDP, 1, 2, 3, 4, 5, 6, 7 DVLSPs, something about Dropbox LAN sync discovery protocol? Dropbox is generating traffic on my network from these different devices. I might wonder what in the world is Dropbox doing to make my network busy. There's DHCP traffic. DHCP request and discover. Those are broadcast to everyone because they don't know the DHCP address of their server. They're sending it out to everyone on the network. Hey, are you a DHCP server? Give me an address. 1, 2, 3, 4, 5, 6, 7. 7 in a minute. DHCP v6. You can count them if it's a small number. If you have a ton of them, remember what you can do. There's a lot of ICMP v6. I want to count those instead of by hand. I just put up here in the capture or display filter ICMP v6 and hit enter, and then I can see down here there's 111 ICMP v6s. So all I'm asking you to do is doing a little practice with these display filters, knowing how to capture now or display from somebody else's capture, and I hit enter after changing the filter, the various protocols, and there's not a ton of them, but you can imagine what you can learn about networking by just going through these various captures. Like for now, I don't know what IGMP is until I click on that. Wait a minute, it's a router solicitation, it's a multicast listener. We have people doing multicasting on our network, and I'm kind of curious, what's going on with multicasting with this IGMP? There's ICMP v6s. They're talking IPv6 generates different traffic. Then there's this IGMP. There's actually a multicast going on, and if you actually click on some of these, you'll see in the MAC address display, it actually will filter out what it knows to be that particular host type. Like some will show you Apple in there, knowing that's an Apple machine generating some of the traffic. But all I'm asking you to do is just do a count of each type of protocol, just to get a little practice with wireshark forensics.
Why can't I filter IGMP-v2?
Let's see. If I put IGMP v2, what happens? IGMP. Oh, it doesn't want to know. It only can filter out IGMP and won't give you a v2. That seems like a. Why would that do that? I guess I can sort by program. If you can't filter out on both, and there's a ton of them, just show that you did total IGMP of 83. If you want, don't worry about having to count them exactly. There's mostly V3s. You want to count them 1, 2, 3, 4, 5. I didn't realize you couldn't just name each protocol. So IGMP total. Just discard the filter, hit enter. Go back to the broadcast filter, enter. IPv6. Oh, look at that. Just a couple IPv6s. Ton of LLCs. I don't know what that is. I haven't researched what LLC is. But let's see how many there are. 86 LLCs. If you want to investigate, some of you that are curious, all you got to do is open up the frame and start exploring what you see down here. And sometimes they explain what it is. Logical link control, that's what LLC is. Not a lot of data in it. The frame has a lot of the information about, let's see, do we have MAC addresses involved? Oh, it's being broadcast. Here's my source, so I could search through my switches and find out where is this device sending me this strange LLC traffic. You could actually trace it down to the actual port on the network and find out. It does say DNM Holdie, whatever that means. It recognizes some vendor in the first 3 bytes of the MAC address. So you don't have to do them all. Do as many as you can, and then let's see, there's not too many. So STP, it looks like, let's see. Oh, STP also shows up in LLC. That's weird. Irritating. Let's see if I hit enter. Okay. Yeah, STP, even though I do a filter on LLC, I also see STP protocol. That's interesting. The better you can get and more experience you get with Wireshark, you will be good at troubleshooting and forensics and security. You start learning about what's going on. Broadcast address can be very annoying because it goes to everyone. So if I'm a virus and I found some vulnerability in network protocol, first things I'm going to want to do is, if I want to attack a network, figure out how can I broadcast these deadly bits to everyone on my network. You can somehow construct a PC killing packet, and there were some vulnerabilities, some 0-day exploits that you sent a poison packet to a specific machine, you could cause it to shut down. It was done to me by a student that was big in this. I'd like to know what he's doing now. He shut down my machine at the instructor desk just by sending me a malformed packet. And I thought, well, that was interesting. How did you do that? He never explained it. But he didn't do it anymore. I immediately turned off my student LAN network interface. But imagine the things you could do. If you discovered a way to malform a packet that you could broadcast to the network, that would either shut down the machines or open up a back door into the machine, that would be a very powerful piece of malware. So if you know that kind of malware will be around, on the blue team, you will have to put some type of filtering in on your network to watch for those packets. And every router, don't forward them. Well, they're not going to forward broadcast traffic. So how would you defend against something that could shut down every machine with a poison packet broadcast?
Send it back to where it came from.
You could, if you found something like that, you could probably be famous. You could hold the world ransom. I mentioned there's people out there looking for that kind of stuff. Do a brute force. Form random packets and broadcast them. There is actually a way to do that. Maybe I'll come up with a little exercise for you to use a tool that's freely available to construct a broadcast message, just to send your name out to everyone in the data part of a broadcast packet. All right. Just upload your results so I can see you did this. And I think it's good practice for you. We'll be doing more on variable link subnet masking, and I'll look through the labs and kind of highlight what I'll see as the really good information to really get you well versed in that. Have a great day. And I recorded this, Jared, for you. I will upload that to my CCNA channel.